All right, you're going to hate this one. We're going to solve some linear word problems. It's going to take us a long time to get through this, so be patient. So when we are solving linear word problems, there is absolutely nothing on this slide. So we're going to, oh, look, there it is. We're going to decide what information is important. We're going to figure out what the question is asking, assign a variable to what is not known. Okay, these go together. We're going to figure out the question that's asking. The question tells you what the variable is going to be. We're going to write an equation using the information given. I'm going to solve the equation. We're going to answer the question, and let's get started. So here's what I read. Write an equation and find Jack's number. So we're going to let J equal Jack's number. Oh, that's horrible. That's messy. Messy, messy, messy. Okay, so Jack is thinking of a number. Not important. Great story. 8 more than tells us we're going to add. Now remember I said than. That means we're going to start behind the word than. Behind the word than, it says the product of 5 and the number. So what's the product of 5? Product means multiply. So I'm going to take 5 times Jack's number. What am I going to add to that? 8. Is always your equal sign, 93. All right, just write that down. We'll worry about solving it later. That's all we're working on with the notes right now is how to set up the equation. All right, Jill is thinking of a number. Jack and Jill went up the hill to fetch a pail of water. Boop, boop. Okay, 6 less than 2/3 of the number is 14. Write an equation and find Jill's number. So we're going to let J equal Jill's number. Okay, so now we're looking for the word is. Remember I said is always equals. So we know it equals 14. We got to go back here and find some clue words. Less than. Less means subtract, and the than says start in the back. So behind the word than, it says 2/3 of the number. So 2/3, that's 2/3 of means times what? Of the number, which is J. Less means minus, and then we work in front, and we want to subtract 6. Okay, so look for the is. Is your equal. Start there. Look for the operation. I got that from less than. Than tells us I'm working backwards. So behind there was the 2/3 of the number. And then what did I want less than that? 6. Papa John is 50 years old. How old is Jimmy? So we're going to let J equals Jimmy's age. So Papa John is 50 years old. That's important. So we know Papa is 50. Let's see what else we know. His age. What is Papa's age? Papa's age is 50. Let's write that down and then look at that clue word right there. Is. 2 years. Here's our favorite word. More than. So we're going to start behind the word than, which happens to be over here. And we're going to take 3 times the age of Jimmy. And then what's in front of the word than? We want to add 2 more years. Again, all I want you to do tonight is write them. I don't want you to worry about solving them. How old is Mr. Johnson? So let's let J equal, apparently we like the letter J, Mr. Johnson's age. That's what we're trying to find out. So Mr. Johnson said 5 less, whoops, there's less than again. That's our minus and tells us to work behind, but let's look for our is. Is, there it is. So we know it equals 12. Less than is a minus. Behind the word less than, it says 1/4 of my age. 1/4 of is multiply. My age. Whose age? Mr. Johnson's age. And then how much less than that do we want? 5. So again, is your equals. Less than tells you to subtract, but to work backwards. So behind less than is 1/4 of tells you to multiply his age. And how much less? 5 years. Amy, blah, 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 blah. How much does her father weigh? So we're going to let F equal her father's weight. So Amy weighs 92 pounds. So we know that 92 is Amy's weight, right? So I bet we found, oh, look right there, her weight. What are we going to put for her weight? That's 92. And then here's our favorite word, is. So I've got 92, her weight, is our equals. So everything else is going to be on the right-hand side of the equal sign. We're looking for our sign, our plus, our minus, our times, our divided by. And there is our more than. More than says we have to start behind it. Well, behind it is all the way over here. Half, there's that of again. So half of means multiply. Her father's weight. What's her father's weight? F. And then how much less do we want? She is 6 pounds less. A banana has 80 calories. This is the blah, 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 blah. How many calories are in a banana split? So let's let C equal the number of calories. So the banana is going to be 80 calories. So when we see the banana, we're going to put an 80. Do you see the word is? So there's my equals. In front of the is the word this. What does this refer to? It refers to the banana's 80 calories. So this is my banana's 80 calories is, now let's look for our more than or less than. There's less than. Less than says we have to start behind, and what's behind? 1/7 of the calories in a banana split. There's that of again. 1/7 of means time. The calories, right? There's our calories, C. How much less do we want? Less is minus, and we want 5 calories less. All right, Janie, blah, 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 blah. Uh-oh. Look at right here. It says inequality. That means we're going to have either less than or greater than. And we might have to have equal to. We'll find that out, okay? So write in and solve an inequality to determine how many chores Janie needs to do. So let's let N equal the number of chores. So Janie receives an allowance of $3 a week. In addition, she can earn $2 for each chore she does. This week, so let's talk about this week. This week, how much does she get for this week? Well, she automatically gets those $3, right? Then it says she can earn. Earn means we're going to add. How much are we adding? $2 for each chore. Well, how many chores did she do? I don't know. So it's $2 for each chore. So if she does one chore, it's $2. Two chores, it's $4. Three chores, it's $6. So we're going to multiply however many chores she does times 2. So this is what she's got this week. And then when we go to the next sentence, it says, this week, what is this week? Right there. 3 plus 2n, that's how much money she has this week. She wants to earn enough money to buy a CD for $13. So in order to buy a CD for $13, she needs $13, or does she need more than $13? She needs more. They have that horrid thing called tax, don't they? So we want to know if she has enough to buy that $13 CD. So she would need more than $13. If she had exactly 13, can't buy it. Tax, Uncle Sam. Pshaw. So let's put in here one of those secret words. The secret word here is Uncle Sam. So put that in your notebook, put a little star around it, and put shh. That's the secret word. Okay, example 8. Brenda has $500 in her bank account. Every week she withdraws, blah, 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 blah. How many weeks can she withdraw this money if she wants to maintain a balance of at least? See that word at least? At least is what happens when you go to Kings Island and you want to ride the roller coaster in the loop-de-loop, okay? There's a little guy standing right there, and his little hand says, you must be at least this tall to ride the ride. So can you be shorter than that? Nope. So at least means greater than or equal to. If you are that tall, you can still ride the ride, or bigger. So we know we're going to have a greater than or equal to. So let's see what's going on in this story. She has $500. So right now, Brenda has $500. Every week she withdraws. She's not getting money if she's withdrawing, is she? She's subtracting money. And how much is she subtracting? She's withdrawing $40. Now, she doesn't do that just once. She does that every week. So we need to multiply it times our W. $40 for 1 week, $80 in 2 weeks, $120 in 3 weeks. And we want to know, she's not going to put any money in, how many times can she do this and still have at least, that's our greater than or equal to, the $200. All right, we're going to spend a lot of time talking about these guys. So consecutive integers, here's what consecutive integers are. They're numbers that follow each other. So for example, 1, 2, and 3 are consecutive integers. -4, -3, and -2 are consecutive integers. Looks like they're going backwards, but remember, when we have 0, there's -1, -2, -3. We always start with the little number and go towards the bigger number, okay? So we have our example right there. Look at that. I was ahead of the game. Consecutive even integers. So if my first integer is 2, the next even integer is 4, and the next even integer is 6. Well, what's in between there? An odd number and then another odd number. So how do I mathematically get from 2 to 4? I add 2. And then I add another 2. So from the beginning, I add 4. So I'm supposed to fly in here. Guess what? Consecutive odd integers are 1, 3, 5, and what's in between those? An even number, an even number. So I add 2 to get to the next one. To get to the second one, I add 4. Okay? So we're going to have a little chart that looks like this. We don't know our first number, so we're going to call it X. So consecutive integers are like 1, 2, 3. So if I call this X, how do I get from 1 to 2? I add 1. So my next integer is X plus 1. Now I always have to go from X. So how did I get from 1 to 3? I add 2. So my next is X plus 2. Consecutive even integers start with X, but remember they're like 2, 4, 6. So this is my X. How do I get from the 2 to go to 4? Mathematically, I add 2. So my next one is X plus 2. Always got to start from X again, remember. So how do I go from X to get to 6? I added 4. So it's X plus 4. Remember, the reason is we aren't going to the very next number. We're going to 2 numbers after. So the next one's kind of weird because odd integers are 1, 3, 5. So you'd think you'd want to add 3. But remember, this first one's X. So to get to the next one, from 1 to 3, what do I do? Oh, bad choice of colors, Jackie. Add 2. So my next one is X plus 2. Then to go from X to get all the way to 5, I'd have to add 4. So to get to my next one, it's X plus 4. So here's the deal, guys. These two are exactly the same. So it doesn't matter if they're consecutive even or consecutive odd. If they are even or odd, it's going to be x, x plus 2, x plus 4. So we're going to find 3 consecutive integers whose sum is 42. So sum means we're adding. And the is right there is our equals, and we want 42. Now, what did I tell you we always start with? We always start with x. So here's what you're looking for. It just says consecutive integers. It does not say odd. So to go from this number to the very next number, I add 1. To go from this number to the next number, I add 2. Now here's what's really bombo about this. I have x, x, x. How many x's is that? 3 x's. And I have a 1 plus a 2, so it's plus 3 equals 42. They're always going to look like that. If it says consecutive integers, it's always x, x plus 1, x plus 2. If it says consecutive odd integers, first of all, it's only 2 of them. So I'm adding 2 of them. They have a sum that is, at most. Here's the deal with at most. This little person's at the park, but now you're in the kiddie section. He says you can be at most this tall to ride the ride. So can a giant ride the ride? No. You have to be less than or equal to be at most. And what do we want to be at most? 56. So remember, we always start with x. Now odd means we're skipping that even and going to the odd. So what do I have to do? I have to add 2. Okay, find 2 consecutive integers. So I'm going to go blank plus blank again. Oh, well, I'm not if my pen doesn't work. Dag nabbit, what's going on here, folks? Come on, it's not writing. I'm pushing on the buttons, guys. I think I have a problem. I'm going to pause. Okay, I'm starting again. Look, see, sometimes you have to power down, power up, and I just did it in my head. 2, here's what you're looking for. Consecutive integers. Does it say odd or even? Nope. That means starting with x, we want the very next number. So that's going to be x plus 1. Now it says, those are our 2 numbers, but they don't want us to add them this time. We want, this is weird, 7 times the smaller. This is the smaller, remember? I want 7 times that, so that's 7x. See the word is? Remember, is my equals? Well, this time it says is less than, so I need to put a less than sign. The word is either going to be equals, greater than, or less than. And then it says 6 times the greater. Well, this is my greater integer, so it's going to be 6 times that whole thing. You're going to need parentheses there. Romeo and Juliet, Romeo, Romeo, wherefore art thou? We're 270 feet apart. So here's Romeo, here's Juliet. Whoops, that's poor. Look at, she's all bent over, poor little woman. There she is. She's got heels on. Very hard to run in. They were 270 feet apart. Romeo starts running towards Juliet. Juliet begins running. Whoops, it's not writing again. Switch colors. Towards Romeo. Okay, how many seconds after they started running will they meet? Now here's what's important. He's running at 16 feet per second. So he goes 16 feet in 1 second, another 16 feet, another 16 feet, another 16 feet. So we're going to multiply that times x. We're going to let seconds equal x. I would use an s, but it looks like a 5. So I'm going to use an x. She runs at 14 feet per second. She's slower. She's got on heels. So it's 14 and then 14 and then 14 and then 14. So we're going to take 14 times every second she runs. So this is that's how far they've run. That's their distance, okay? So what we want to know is when will they meet each other. So Romeo's distance plus Juliet's distance is going to be, oh, I said is, that's our equals, our total distance of 270. We're going to solve these later, so let's just move on. All right, so here's your recap. Decide what information is important. Figure out what the question is asking. Remember, that's always the last sentence. That's going to tell you what you're looking for. Assign a variable. You get that from the last sentence. Write an equation. You're going to look for your clue words. Solve it and answer the question. These two we're going to address in class tomorrow, okay? Still pretty long video, guys. I'm bad at this. Have a good day.